So in my last video we discussed about the structural isomers and ring isomers and position isomerism. So now it's turn that we will discuss about the functional isomers. Functional isomerism. Basically, functional isomerism means that compounds having same molecular formula but different functional groups are basically known as functional isomerism. For example, we have a formula which is C2H6O. This is the formula of basically, let's consider this is a formula. We need to make two different structures from this. So let's make the first structure of ether. Right? What is the formula for the ROR? So we make CH3O CH3. This is basically ether, right? Ether plus we can also make CH3 CH2OH, which is basically this is ethanol, right? So we can say that ether and alcohol have same structural, they have same molecular formula but different structural formula. So ether and alcohol both are what? These both are functional isomers, right? Now let's look into another example of, for example, let's take ketone and aldehyde. Let's consider, we will take CH3 C double bond O and CH3. This is considered, this is acetone, right? Now let's consider CH3 C double bond O H. This is acetaldehyde. Acetaldehyde. This is basically this is propanol. Here we have 3 carbon, right? It will be like CH2 CH3. Now we can say this acetaldehyde, right? So these both have basically same molecular formula but different structural formula. What is the molecular formula of this? C3H6O. This is 1 2 3 C3H6O, right? So basically these both have same molecular formula but different structural formula. So we can say ketone and aldehyde both are what? Both are functional isomers, right? So now take examples. Let's consider basically alkanes, cycloalkanes and dienes, and basically alkenes, alkenes, cycloalkanes and alkadienes. Alkenes and cycloalkanes both are basically what? Both are both show functional isomerism. So the formula will be CnH2n, right? But if we talk about alkyne, cycloalkene and alkadiene. So their formula will be CnH2n minus 2, and these three will show the functional isomerism. Let's take more examples. For example, we take ether and alcohol. The formula will be CnH2n plus 2O, right? If, for example, let's take the ester and carboxylic acid plus cycloether and cycloalcohol. Basically, this cycloether is also known as epoxide. So they also show functional isomerism. So their formula will be CnH2nO, right? Another group, which is basically aldehyde, here aldehyde and ketone will come. Aldehyde and ketones formula is CnH2nO, right? But here, if we talk about carboxylic acid, and if we talk about ether, if we talk about hydroxyaldehyde, and if we talk about hydroxyketone, basically these four show the functional isomerism. So their formula will be CnH2nO2. This was the formula of carboxylic acid, ether, hydroxyaldehyde and hydroxyketone, right? You must learn these formulas, that for basically alkene and cycloalkane, CnH2n. Then we have alkyne, cycloalkene and alkadiene, CnH2n minus 2. Then we have basically ether and alcohol, which formula is CnH2n plus 2O. Then we have aldehyde, ketone, cycloether and cycloalcohol, which formula is CnH2nO. Then we have carboxylic acid, we have ether, we have hydroxyaldehyde and hydroxyketone. So the formula is CnH2nO2, right? So here we have completed our functional isomerism. Now let's look at metamerism. Metamerism, right? Basically the unequal distribution of carbon chain on both sides. This is unequal distribution of carbon chain Unequal distribution of carbon chain on both sides of polyfunctional atom of polyfunctional atom or polyfunctional group. Right, unequal distribution. For example, let's consider we have CH3, CH2, CH2, OCH3. This is ether. Right, if we arrange this like right, these both are known as basically metamers, right, which is shown in basically ether. They can be shown in ketones. Right, these are basically what metamerism, in which there is basically unequal distribution between the polyfunctional atom. Here this polyfunctional atom is this oxygen is basically this polyfunctional atom. Polyfunctional atom or polyfunctional group. Right, now discuss another type of isomerism, which is known as tautomerism. Tautomerism, basically there is a shifting of hydrogen plus, which is basically shifting of hydrogen proton from one atom to another within same molecule. There will be shifting of hydrogen proton from one atom to another within the same molecule. For example, consider we have a amino acid which is C double bond O, here R, or here NH2, and here hydrogen. If we dip this in water, there will be process of rearrangement and it will be converted into C minus NH3 R hydrogen. You can clearly see that here this hydrogen has been shifted to this. So basically there is a transfer, there is a shifting of hydrogen atom. So now this is basically known as Zwitter. Right, now it's with a positive charge and this is as negative charge. This is known as basically what? A Zwitter ion. So there is shifting of proton from one atom to another within the molecule. Right. For example, we have another example of vinyl alcohol, CH2 double bond C OH and H. This is basically known as vinyl alcohol. This basically will be converted into CH3 double bond. It will convert to acid aldehyde, right? So there is as you can see over here, this one hydrogen is converted into this. This hydrogen is basically shifted to this. So this is basically rearrangement. And still this whole thing is in dynamic equilibrium, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section, and I would be really glad to answer you.